I welcome Pritam Banerjee for this podcast. This is a kind of a podcast where I'm trying to demystify what's an actual data engineering role is all about. Trust me, there is no person who can give you more insights than him because just before starting this podcast, we had a 30 plus minutes of talk just to discuss the right questions to get through what you really require in this field of data engineering. It's not about the software, it's not about the hardware which you're working. It's basically the work that you need to put in and the basic understanding that you need to have before you put your hands dirty for any data set that you have. It gives me an immense pleasure to call a senior data scientist, actually a data engineer who is working on software development, who's also a tech lead, who has his hands on experience in different technologies. So it's a dream come true moment for me because a lot of times when I interview people, it's not their greatness, it's their value that they have added through educating themselves. So it's actually one of the most educated plus the intellectual podcast that I'm going to be conducting right now so that you guys can get the right aspects of what data engineering are all about. So I welcome Pritam Banerjee, sir, for this podcast. And thank you so much for accepting this podcast at a very short notice.
The pleasure is all mine, Vishwas. So thank you very much for this invitation. So it is a nice opportunity for me to speak with you in this podcast. So yeah, pleasure is all mine.
Yes, Pritam sir, we were talking a lot, not just before this call, not just before this recording. Even prior, we have talked a lot about the way in which education system has really ruined the way in which data technology people have to come out. That's where this education system needs to drive us. So I just want to ask you this one question: what's the actual value of real education for a person in order to just get inspired and also just behave like an engineer? And also, what's the actual influence with the science and the conspiracy about our present education system? All about.
Yeah, maybe I mean. So this is a very interesting question, actually, because you talk about the value of real education, right? So because I mean, so now yeah, so probably the way how I want to explain is, so this is my own perspective of this question. So because yeah, everyone has their own definition of the education, right? Probably if you ask Elon Musk, he has a pretty crazy definition of that. So what is the real say meaning of the education, right? So there was a lot of debate so which happened on the education versus intelligence. So yeah, we all have our own thoughts, but so to come back to the question, right, that if I talk about that, what is the real value of it? The value of your education is this, that that when you can apply your education into some real world problem, that is the real value of your education, right? I think probably in our colleges, probably if you talk about the engineering colleges and yeah, maybe in the schools also, right? I think very less percent of the people, they actually learn something keeping this thing in mind, that where I might use it in the future, right? So we always like say learn it. Why? Because we have to learn it. Okay, so we are into, so that is a core academics, and we know that we are into a kind of rat race, and we have to just compete with someone. And that's the way how we read stuff, that's the way how we learn it. And we write the exams, we score, and kind of we forget after 10 years. And that is the case with me, honestly. So when I started my say studies on data science, and when I was like doing a little bit of brush up on core calculus, probability, statistics, I was thinking that that I really passed it. Okay, I mean, like things were a little bit new to me, though I actually have studied and I have scored well. Okay, so in that case, I ask one question to myself, that uh, where it actual value the time that I've spent over there in my engineering, say for example, right? So is it a real value which I can derive right now out of that? I would say no. Why? Because at that time I just have just read that. I maybe I have learned it, and I have given the exams and I've cleared it. That's all, right? But in my definition, that's not the real value of education. Okay, the real value of education is this: is that if you are learning something, think about it, that where you want to use it. And I'll tell you, that if you think about that and if you can relate it to a real world problem, that is education which you'll never forget. You will be at 60 years old, but still you remember the concepts. You don't have to learn by heart, so that is, I feel, that is a real value of education. Okay, because nowadays, yeah, education is kind of, it's a money making industry. Okay, well, I mean, I don't want to comment over there. So there are a lot of courses, a lot of big colleges, but once again, to come back to this thing, it does not matter from where you're doing your education, your course, your degree and all, right? It matters that how serious you are understanding the concepts, what you are learning, and how you are trying to map it with the real world problem. And now as we are into the internet age, right, it's very easy to find out that what you're learning, how it is connected. Earlier in my time, internet age was there, but it was not exactly, that so fast internet. YouTube was, so easily accessible and all these things. So it was a bit difficult for my time to find a relation to the actual learning with the real life problem. But I would be saying that yes, if we can do this thing, that's the real value of the education.
That's true. That's true. Because, when we talk a lot of jargons, we are supposed to know the tech behind it. It's what's
Yes.
happening there
Yes.
behind the hood. You just can talk jargons, but none of them will be satisfied until and unless you
Yeah.
get your hand dirty. You know,
Yeah.
Speaking of all of this, something on education system that we have actually come across, where's the software architecture moving more towards? Why I'm asking you this question is because Redis Lab is there that we were talking about, how it can be leveraged for other processes also. It's not just for your database, it's not just for your container instances to just handle it somehow or other. It's a huge impact about one software being that disruptive. So I just want to ask you this one simple question. You can elaborate it in such a way that people can understand it. Where is software architecture moving more towards?
Yeah, this is a kind of a whole class kind of question, that this is having a good history actually, that how the architecture was started and how the code evolution say happened, because I am still a little bit I would say young to make a right comment here, but still I have seen some nice transition of the things, the time when I started my career. Probably I'm talking about from the last 10 years. Okay, the way how architecture has evolved, the way how I have seen, not exactly what I have read, the way how I've seen. Okay, so probably I'll just give a bit of history about it, so that will be so quite interesting for us to know that how it started and how it's moving right now. So probably, I mean, yeah, if I can just think about of a bit of timeline, right? The first architecture that came into the picture was actually a monolithic kind of, right, which came into the market at around probably the 1960s or 1970s, right? Then so in those monolithic, we have, the client server. We also talked about the P2P. So all those architectural patterns were there, right? So after the monolithic, now we have the basic thing about, that so now slowly on top of that, we got something called a service oriented architecture, the SOA, right? Where we thought about that how we can, create services, and how we can decouple the server and the client, right? So that was the era when so SOA was actually the talk of the town, right? And then after that, it actually slowly moved towards, I would say, say microservices, right? And then, I mean, probably, I mean,
Serverless.
I'm talking about at a high level. Yes, the final thing that is about the serverless, right? And now you think about it, that so this is at a very high level. Okay, now if you go a little deeper on that, right? So this microservices, so these microservices are something which is actually a game changer in the market, right? I mean, though we know that microservices has a lot of cons also. Well, say anything cannot exist without a negative, right? Or negative or a limitations, I would say, not exactly a cons. It's its own limitations, right? But microservices are actually why so famous, because microservices are a kind of concept or a kind of say new paradigm of thinking, where we are thinking about how you break things much granular, right? So when we talk about microservices, we actually so coined some terms called micro brokers, micro gateways, right? So what are these actually? So these were already there earlier, right? So we just added a word called micro, isn't it? So it's nothing. Okay, so it's just like how you can break the things at a much granular level, and how you can get more control on stuff. Okay, and how you can make it more scalable and maintainable, right? So monolithic applications are a bit difficult to maintain if you want to scale it, right? So that's actually a pretty old one, because nowadays even there are few good applications. I can tell you that those are still running in the core monolithic way, and that is performing really well. So that is the thing, that we always should not follow that trend. We should actually think about that, what is the problem statement, the business use case, what we are trying to solve, and based on that we have to plan the architecture, right? So now if you think about it, right now things are moving more towards cloud also, right? In cloud, the architecture are a little bit different. Okay, so if you talk about microservice also in cloud, if you go, it is a little bit different. The core concept will remain the same, but you have to tweak your architecture a bit over there. And now, the one question what you're asked, yes, yeah, this is a great book actually, by the way. Yes, this is a very nice book. Yes, this is a very nice book. Yes, I mean, I also
I
have
have
this
it
book, by
next
the
to
way.
my bed because I'm now reading this book.
This is a very nice book. Yeah, I still have this book with me. So now the software architecture, because nowadays, like say, if you see that the way how software is, the way how we are developing, the way how we are programming, the languages, programming pattern, those are improving, right? So those are evolving. The same way we have to think about how the software architecture can also evolve, right? So if you talk about that, we are right now into cloud. We are we are into the IIoT, right? We are into the industrial IoT, right? So even for that also, we have a different type of architecture, but the concepts can be the same, because you can deliver something by using serverless, right? But the serverless for IIoT will be a bit different if you are building an e-commerce application, right? So that's the way how things are going, and right now what I can see is this, that I mean, so based on my experience, the way forward is going to be serverless. Okay, and well, microservices, yeah, is something that that is actually so taking the market a lot, and the deployment is actually on the containers. That is the way how things are moving. So containerization, I mean, we can use Docker, Rocket, and the orchestration we can do it by probably say Kubernetes or Docker Swarm, yeah, whatever, right? But the way how we are moving is in that particular uh, uh, say in that direction. So earlier, I mean, we never thought about to have containers, or we can have a container orchestrations, or in that. So we talk about in one container we can have multiple applications. So these all things were there. So Docker is not a new stuff, right? Docker came quite a long time back, but it took some time for people to adapt to that, right? So this is a basic journey of any new technology when it comes in the market, and it takes its own time to actually get the adaptance, right? So now what I can see, that majority of the application, because even in my case also, the way how I worked, I started with the on-prem systems. Every servers are actually on our own server, or on the say premise server, right? Then we moved into the basic cloud PaaS services, right? Then we thought about, why not let's go to the Kubernetes. So that's the way how we moved. So, and the architecture also we changed following that particular move. So as I told you, that based on the problem statements, we can go for serverless, we can go for microservices, but the architectural patterns might not be the same based on where you are doing it.
Yeah, when you told most of that monolithic coarse grain architecture, the SOA, and when we just jump on to the microservices, there are memes which can actually demystify what's the actual working. Like in one meme, you can understand, okay, this is the purpose of it. But it's a whole new different story when you're deploying the application. That's for sure.
Yes.
Because
Yes.
speaking of all these, we have Flink, we have Kafka, we have other sort of applications. Flink and Kafka are still the rivals. I would just say go for Flink. I'm still learning it. But like, why anything that we are dependent on somebody who's developing it? I'm just asking, like, why can't we just develop on our own? In simple words, I'm asking you, like, why is there something known as in software dependence that we are actually depending on today in order to deploy anything today. We depend on TensorFlow for machine learning. That's actually the requirement. I can't code it using NumPy. That's for sure. Like, what is it all about? The new era of jargons, the pipelines, the frameworks, the data, and how are they influential in not creating the actual uh, technology actually? It's a very long answer for, I think I'm actually expecting a very long answer for this very short question.
Yeah. So this is a very nice question, but I'll just tell you, why? Because we love to be lazy. That's why. Okay, so yeah, you are right about it. That why we cannot do this. We can do this, by the way. Okay, I mean, so there is no such thing that is stopping us. That we can choose not to use TensorFlow, and we can start to write everything from the scratch, and that will be something that is a home product, and we can build a whole solution by that particular way, right? But you think about it, that probably if I just go a little bit back in the time, so let's go back probably say 20 years. Okay, so when servlet and all came into market, I mean JSPs and all uh, came into the market. So now you think about it, that so servlet, I mean, probably if I take a small example of servlet, right? So what servlet does, it helps us to intercept a request, right? And when you intercept one uh, uh, say any request, and then you can actually take a call on that. So what exactly you want to do with the request? You want to reroute that, you want to probably enhance the request, and then you reroute. You have a concept of filter. All those things came out of the box from Java, right? From the J2EE, isn't it? So you think about it, that those are right now coming out of the box. Now, as an application developer, okay, so your responsibility is actually what? To build those framework or those particular logic who will help us to intercept the request, or your responsibility in a project is to do, once you intercept the request, what to do after that? How do you write a business after that, right? So that is a segregation what we started from that particular point of time, that we use a word called framework, right? And what is a framework? That in the framework is actually what? That it is a set of APIs and a kind of SDK which helps you to just focus into your business problems and not exactly on the technical problems, right? So that is actually a layer of abstraction what it builds for you, right? So that you can actually focus more into the code business, and not into that how you you write the code to intercept a request, or how you write a filter that will be so some kind of component which will be called before your servlet is hit, say like this kind of example, right? So you don't have to focus about that. You know that there is something called filter. There is a defined way that how do I implement a filter, and I will implement that, and I will override some function and will write my own business logic, right? As an application developer, you will think in that particular way. Now you think about it, that how much time it saved for you, isn't it? So because in a project, you always have a strict deadlines, right? So if you think about it, that I have to build everything from the scratch, right? Then you will divert your focus from the business to the technical problem. So maybe in the analogy, I can tell you one small example, that we drive a car, right? So what is the responsibility of a driver? To drive the car, isn't it? To drive the car, to steer the car, right? But we can still build the car if we have all the components, right? We have the engine components, we have the odometer and this on this. So we can think about why not we build our own car and then I'll drive, right? But it is not required, right? So there are some people who are giving you the ready-made car and they're expecting you to drive it, right? Similarly, now things have evolved like anything, so because the core requirement of the framework provider was this, that how I can make sure that all the technical challenges are abstracted, so that the implementation guy, they only work on the business implementation and they don't really have to worry about that how the implementation is being done. So if they have a problem, either if it is open source project, they can go into the code and they can look into that. And if it is a licensed project, they can raise a bug, they can raise a CR and they can get things done, right? Now that is the way how things started, so open source was there from a very long time, but open source is very popular now. Why? Because of the growth of community and because of the adaptation of the open source software, right? Because earlier we were not able to trust the open source software, right? Because we were thinking about the security issues, that I mean, if we are using some framework, what is the guarantee that they're not capturing our data, right? So now things are very matured. We have got the GPL licenses from Apache and all these things. So yeah, Apache is a big father uh, of the open source. So now you think about it, so because the core segregation is being done. Okay, so as I told you, you still can do that. So you gave a small example of Flink and TensorFlow, right? So probably I'll just take example of Flink. Okay, so Flink. So what? How Flink is helpful to us, So I mean, so in Flink, you simply can create a stream, right? You don't really care about how the stream is actually working inside it, right? How the data are actually being packaged and how it is uh, being sent to you to the stream processor. Those particular part is a complete abstraction for you, isn't it? So you just know that there is a defined implementation from Flink that I'll have to use a sync or a kind of code injection, probably from Kafka or from Amazon Kinesis, anywhere, right? And then you know that if the connection is established, I will be getting data from that particular queue. You don't know how it's coming. If you want, you can know that, but it is additional knowledge for you, isn't it? So for you, the core thing is this: once you receive the message, what you do on so let's say on that is a business problem. So that means what? Flink is doing majority of the technical work for you, and then you are expected only to work on the business problem. So it's a very help for me, right? I mean, me as an application developer or me as a product owner, I can have a stricter timelines. I know that I don't have to say work on how the message things are coming, how the message guarantees are working. Those things are being given by Flink, right? So for me, that I know that Flink has given a guarantee that I'll be getting the message. So there'll be no message drop. Okay, and I can be rest assured that I will get all the message, and I just have to make sure that all the messages are being properly processed and things are persisted, or probably that you have a pipeline. Okay, so that is the advantage, and that is the reason people are nowadays more moving towards that we call it as a managed solution, right? So in cloud, we actually call it as a managed solution. Why we go for that? We are paying a heck lot of money for that. Still after that, we're going for it. Why? Because of this reason, that we want to focus on the business and not on the infrastructure, not on the platform, not on the servers, not on the servers highly your servers high availability. Those things are being maintained by someone else, and I just want to pay him. That's all. That is the way how it works, right? And this is so quite good. And nowadays people are moving more towards SaaS, database as a service, all as a service. Why? This is the reason. Though, yes, you are right. We lose the control, that we don't actually get to see end to end, but it is fine because we don't want to, so have a focus in that. We want to focus only on the business.
Well, thank you for giving me such a precise answer, because we discussed a lot, but you created it back in nutshell. Thank you so much for that. So speaking of that, we pay a lot of money, but Apache is also kind of a big father, a godfather of open source. We have seen how Linux was actually built, and everything is actually dependent. So I just want to ask you this one stupid question from my side. How is the trend of Apache and data science working out for the world?
It is actually pretty good, because nowadays Apache is doing amazing work in the data science tool. Okay, but yes, Apache is majorly into the Java side, Java, Scala, and the JVM side and all. I mean, they do have projects in Python also, but not that much actually, right? But still, the contribution from Apache into the data science community, probably if I talk about data engineering community, right? So if you
That's
think
your
about all
world.
the open source,
Everyday
yes,
world.
that's my world. Yes, right. So if you talk about all these things as Flink, Spark, right? So these are all under licensed from Apache, right? So nowadays the majority of the Spark development is being done by Databricks, right? And so even Kafka is Confluent. But you think about it, that these are all open source. At the end of the day, if you want, if you as a product owner, if you want that, I do not like, I mean, probably if I speak about a small thing on Spark, okay, I'll just go a little bit technical in that. So Spark has something called RDDs, okay, and data frames, right? So if you think about it, that hey, I mean, I somehow feel, that the way how Spark has written the tungsten, the core catalyst optimizer, I can improve that. Okay, now you have two options. You have an option that you can do that only for your project and make sure that the build is being managed by you, and the build is not being managed by the code release from Apache, or you can do a contribution in that, isn't it? So that is the way how community works, right? So because I mean, you actually talked about Linux, right? I just don't recall the exact numbers, but Linux, you will not believe, that how much time it took to build Linux. It is a amazing number. I just don't recall the numbers right now, and the only way how it was possible was the open source contributors. That is the way how Linux was created. It was so complete, like it was a POSIX OS. It was so complicated OS, right? But it was being built in a record-breaking time. And the reason was this about the community. If you have a stronger community, right, your tool, your framework can grow like anything, right? So that is one of the things that Apache has a major contribution in the data science world. Why? Because a lot of projects are actually, being created, and so nowadays, so Apache actually have so increased their incubation line, project line. So they have, I think probably they have something called the top level project, and then the mainline project, and they have the incubation project, right? So something like this. So that is the kind of release pipeline what they use. Okay, probably I might be wrong here, like in the name, but they have some 3 or 4 stages there. So based on which they make the release, right? So nowadays, so Apache is actually working in a lot of small projects, which is actually say contributing to the core data science world. So yeah, I think it's very big right now, and even now, if you think about it, right, in data science world or data engineering world, in database world, in the NoSQL, right? So if you talk about it, Neo4j, new so Neo4j is heavily used. I mean, like if you talk about graph database, right? So if you talk about the column DB, so we use heavily HBase, right? HBase is actually open source, right? So we are heavily using the tools from Apache. So from data engineering, I'm speaking on from data engineering point of view, we are heavily dependent on the Apache project,
Yeah,
and we are
when you
very
told,
proud of that actually.
yeah, when you told about Spark, I felt the heat of installing it for the first time. Yeah, it's very difficult to install it on first time. That's for sure. Of course, we actually talked about how batch processing is gone. It's all about the stream tomorrow. It's all about streams,
Yes,
real time.
yes,
Every data
yes,
will just keep rolling in and out of the server, and you have to just keep processing it. That's for sure.
yes,
Like,
exactly.
I just want to ask you this one question. How did you get involved in all this process of data engineering and data management? And of course, you can describe it in your way, but like, how was that journey all about to you when you just started as a beginner, just for understanding the actual workflow? How does the work of a data engineering profession, actually a data science profession, which is dependent on data engineering, works in the current life cycle of software development?
Yeah, this is a very interesting question, actually. Yeah. So, for me, I am actually working in the data engineering world for now almost around 5.5 years. For me, I mean, probably, as you would know, that I actually worked as a full stack developer. I have actually played multiple role into the code development. I have played a front end developer, as a full stack developer, back end developer, Python with Django developer. And even I have worked with the very traditional technology as Camel, Apache Camel, then EJBs. So I
Thanks
just
to
have this
Chetalima.
diversified. Then eventually, I mean, I actually so I have my brother. I mean, he's into the code genomics. Okay, so he speak a lot about that they deal with the huge amount of data about human data, about gene data, and that's actually in zettabyte of data actually. Okay, and that zettabyte I'm talking about some almost 6 years back, right? So yeah, even at that particular point of time, also storage was like going cheaper and cheaper slowly, right? So nowadays, like storage is like pretty cheap, right? So that is the time I'm just talking about. So I was like quite interested about it. So just like you, I started my own studies about it. That how so what is big data? I got my first hands on big data, and I learned the concept of 3V. That so big data has something called 3V. It's called the volume, the variety, and the velocity, right? So that is something, that is a way how I started learning about it. That is the type of data, source of data, and how do you actually so handle multiple source in terms of binaries also. So nowadays Spark has by default support of binary, but earlier it was not there, right? So binary data are one of the most complicated data. So I learned about what is structured data, semi-structured data, unstructured data. So all these things were a kind of buzzword for me at that particular point of time. I also did some courses and all, and then I was quite fortunate enough to actually got a project, and that project was a very interesting project. So that was actually on the connected vehicle, so where we collect data from the vehicle at a real time, and we provide connectivity solutions. So that is a real time vehicle data what we are capturing, and on top of that we do the analytics on top of that, analytics, machine learning, and so all these things are there. And also the project which I started, like it was a project from scratch, right? So where we actually get an immense opportunity to explore stuff. That shall we use this, shall we use that, if that's not right, why is not right, right? So like this we have done a lot of experiments. Okay, so those time were the hardest time for me, because so things are new and I was experimenting, I was doing POC, I'll have to tell why things are not working, I mean why this is right. So that was a very hard time for me, and I was like thinking, oh my god, data world is so difficult. And I really wanted to always learn the data engineering first, because at that time also I knew data science, of course, because machine learning is not a new stuff, right? Machine learning was there from, I think, 80s, probably 70s, I think, probably, right? So I want to learn that first of all, how do you actually tackle data, how do you work with data, how do you actually manage data? So that is the area where I wanted to actually explore first, and get some good knowledge on that, because that is what I learned from my brother, that that he always says that if I do not have right data, I don't know how to work on it, right? So we are heavily depending on the engineers, that how they are processing it and how they are cleansing it. So there's something called pre-processing of data also, right? So how they're taking care of that particular process, and how they're effectively storing that data into the database, so that you can do a proper analytics on top of that, right? So that was the part which was like quite interesting for me. So I gone through multiple tech stack. Maybe I can take some names. I
Yeah,
learned
you
Storm,
can, you can.
Apache Storm, and then Spark. The time when I started the Spark, it was 1.2. That is the version I started, and now we are into 3.2, right? Then we learned about Phoenix, Apache Phoenix. That is actually a kind of query engine like Presto. And then we had to learn about the NoSQL servers like HBase, Hive, and then we thought about, shall we use Pig also? Then we thought, no. I mean, like, so Pig is not the right way. Let's actually do everything in the say Spark only, right? So like this, we have done a lot of exploration. We actually gone for Hive Tez, the Tez runner, okay, and so probably I can just tell one particular thing, that one thing which I learned from that particular experience was this, that what is the expected skill sets, or what is like really expected from one data engineer, is this, that we should know how to effectively model a database, right? That is very important. So because that will decide that how your data will be stored, how your data will be fetched, the that will decide that how your read latency, write latency will be defined. And then on top of this, it's very important. I'll just mark another very there, is this, that you have to learn the ETL flows, the ETL and the ELT. That is called extraction, transformation, load, and extraction, load, transformation. So that is what we actually that we use somewhere in data lake and in the data warehouse. Okay, that
Elastic
so
is
that's the
actually the
concept.
main player in this.
Exactly. Yes. Yeah. Right, you are right. Yes. So this is one more important thing. And yes, programming. Programming is, of course, because data engineering, that our data engineers are not so separate than software engineers. We are software engineers, by the way. Okay, it is just a specialization on top of software engineering, because you need to be really good in programming. Really means really good in programming. Okay, that or some language. You can actually probably work on Scala, because for me, I was a core Java guy. Okay, Java, and I came from a Python background. So for my project, we decided that let's go for Scala, right? So that was also a kind of learning for me, that why Scala first of all, because as it's a JVM language, but still we have to go for Scala. Why is it like this? So that was so kind of learning for me. So probably, as a language wise, as a data engineer, I think probably we have to be very strong first of all in SQL, because though SQL is pretty old, but still SQL rocks. Okay, even nowadays also SQL still rocks. Okay, that if you are good in SQL, I mean, data world is like in your hand. Okay, and then probably some kind of say programming language, probably say Java. I mean, Java is something that is not so much used. Okay, but I would say Python and Scala particularly. Okay, and knowledge on the DB. Okay, so DB, I would say about the SQL Server, of course, and also about the NoSQL Server. And yeah, in NoSQL Server, we should at least know one key value, one document, and one columnar, at least one of the major provider. That is very important, because that will help us, that probably, so a lot of projects, they work on multiple database, not just one database, right? So that will be helpful. So that's the way how I started, so that's the way how I started. And so with this, I spent in that project for now more than 5 years, right? So we have actually built a lot of cool features. We have faced amazing problems. Okay, we have implemented a lot of cool techs, because the whole project was built into Azure, right? So, and for me, that was even the first, I would say, the introduction to cloud computing. Okay, so I started with Azure, and then I learned about GCP also a little bit, but that is on my own personal interest. But professionally, we were so heavily working with Azure. So in Azure also, the core learning was very interesting. So I would say working with the IAS, with the PaaS, with the serverless, uh, with their say data, big data, a PaaS solution. So all these things, right? So that gave us an immense knowledge that why cloud. So what is the advantage of cloud? Because nowadays for data engineers, it is very important that they should know how to work on cloud also, because that is the way forward. Okay, so there will be very less projects going forward from all the industries or from all the companies, that where you will find that they are in on-prem. Majority of the places you'll be finding they are either on one public cloud, or they are on multi-cloud, or they are on hybrid cloud. So, but the cloud thing will be there. The on-prem is a little bit going away. So that's the kind of trend which I'm seeing right now. So cloud will be a great addition to actually see that how or where you will run your jobs or execute the programs.
When you told about everything, it basically covered what do we actually require to understand the principles of data technology, the fundamental principles of data technology. Now I want to just go back to the core schema concept where we are actually working on. Somehow, even if the software technology evolves to 100 version, schema is going to be there. Somehow, Lambda, Kappa architecture is still going to be the stream. What's the core modeling principles that we need to know when we are designing a schema in a database? Because I know it's a very tough choice to actually go through the principles and do it, but like, how do we actually try modeling it for the database? Because you are a data engineer, so I want your perspective now.
Yeah, actually, so you're right. Yes. So, that as I told you that for data engineers, so this is the primary thing that how we can design a DB, right? And how effectively we can store our data, right? And for this thing, yes, you're right. Schema is very important. And yeah, particularly if you talk about say NoSQL, there is no logic of schema, but still we do have that because we still have a structure kind of thing. But if you go for core, the core NoSQL, where usually we say, the schema is something is this, that your schema is on read. The time when you read that, at that time you actually said define the schema, and the schema is not defined on the right time, right? So there are probably so there are multiple techniques actually by which I mean we do the data modeling, right? So this, like, the thing is called data modeling, right? And for this there are the core few say concepts that we use is actually that we use something called the conceptual modeling, right? Then on top of this, we actually use something called logical modeling. Okay. Then on top of this, we have something called the physical modeling, right? So that is a, so when we go for physical modeling, that is the time when you talk about that in what particular database you are trying to do the model. So based on that particular thing, you actually think about that. So what is the support that you get from that particular DBMS, right? I mean, say for example that you are trying to do some modeling for say RDBMS, and the RDBMS provider is MySQL or say Postgres, right? So based on that, your physical modeling layer will be talking about that particular thing, the core thing. I mean, who is giving the code implementation, right? And then you also have the ER models. Right. So ER models still play a very important role. It does not matter that you are into NoSQL. So wherever you have tables and wherever you have relations, right? So you can actually use the ER model, right? So because nowadays, that we have the schemas are actually have multiple definitions, I mean, if you go for data warehousing concept, right, and not code database, right? So data warehousing has something called, star schema and the and snowflake schema, right? So the concept, like say, if you actually go deeper into the concepts, right, the concepts will be exactly what you have learned in your database. So when we talk about normalization, we talked about 1NF, 2NF, 3NF, where we want to break down the tables, and we want to normalize the table so that your data is actually say highly decoupled, and you can have a proper relations, right? So these concepts are being used in the data warehousing also, where we that where actually they uses a name called fact tables, dimensions tables, and all this in the data warehousing world, right? So in data, so once again, coming back to the main question, the core technology what we are using is those the way how you find out the schema, because schema is something that comes at a very later stage, right? So that is the final stage where you actually say define that how your schema will look like. So what is the type? Okay, so we call that as a varchar, we call that as an integer, we call it as a blob, whatever, right? So that is the code schema, right? But that comes into your when you go for the probably like say physical planning, right? So these are the core I would say the core technique. I mean, so what we actually keep in mind. So when we start a design, I mean, probably say, I can give you a small example, that probably that if you are trying to create one database for a pizza shop, right? So, I mean, so how you will say start the thinking, right? So you start the thinking based on entities, right? So you start the thinking based on entities, that how many entities you have, right? Then you think about what are the relations that you can create. And then, so for each entity, you will think about what are the attributes that it should hold, right? Then you think about that each attribute will be of what particular type, right? Then you think about the relations. Then you think about that how you break it down, right? So if you have one entity, can you break it down to one more entity and create one-to-one, one-to-many, many-to-many, yeah, whatever the relationship that you want to create. That's the way how you start thinking about the database designing, right? So in that thinking process, right? So there are some advanced tool, I think probably, I mean, the one which I was using is actually the one from Toad. So there's a tool called Toad, I think. In that actually you can design it. So they have got a nice UI, and you can actually create drag and drop thing, and you can create your say, ER diagram, and that ER diagram also gives you the table structure. So that will give you a SQL file, and that will also give you the tables. So that is one of the way, that how you start from a logical plan, sorry, from a conceptual plan, then you build a logical plan, then you eventually build the physical plan. And then you actually, so while doing say while in the physical plan, you can think about how you build the I mean your say relations also. So that's the way how it usually works.
Yeah, no, that's true. That's true because I think Toad is basically a DevOps version for the data engineers, kind of. A DevOps version for the data engineers, kind of. It's not like
Yeah.
you, it's like, it's not like we just doing the CI/CD or just looking for what's the process which is running at every given
Mhm.
point of time. You just have some sort of a visualization. You just move around it.
Yeah,
That's it.
yes. It actually, have a very nice support for the visualization, because the point that
Yeah,
you told about it, right? So visualization is the only reason why I go for
I
that
go.
personally. I mean, I had actually worked with DB Visualizer earlier, but I was not so impressed. I mean, so Toad has, some nice cool features. You can do reverse engineering and all this stuff. These are things which you can do it in DB Visualizer also,
Yeah,
but Toad is like, too refined. So that's like pretty good. So modeling wise, it's good, of course, but as I told you, like it's a personal choice, that I mean, we
yeah,
have n number of tools. So tools is something that you cannot actually say that this is best or that is best. It is just a kind of instrument that helps us to deliver
deliver
a bit
some
faster.
stuff.
Yes,
You know,
exactly.
I told DevOps in terms of like we suffer a lot when we are actually seeing the data. So I think probably it's going to be helpful when you're trying to do it.
It's very important, no? Because so when we actually create architecture, right? So in the architectural document, so we create something called SRS. Okay, that is called software requirement specification. Okay, and in that we also have to include high level design, low level design. All these things have to be there, right? So in that one of the document which is called your data modeling. Okay,
Mm-hmm.
and in the data modeling you have to give the ER diagram, right? So you have the option that you can build it in the Draw IO or MS Paint, whatever you want, or you can use some tool, so that's completely up to you.
That's
But
good.
those kind of documentation is something what is required for a product.
Yeah. Last question, you told your brother works on genomics, and that's a kind of a data which actually requires a lot of big O notations to some extent and algorithms which try to influence in a very big fashion. I just want to ask you this one question. What's the actual influence of big O and algorithms in order to build a very stable data architecture that we just want to deploy it? Or let it be in terms of data engineering, let it be in terms of the deep learning model. What's it all about? Algorithms are now moving more towards the AGI aspects also, but your big O is nothing important in your data engineering because you just throw GPU, TPU cycles because you don't care about it. You just want to deliver the project. So, what's it all about when it comes to big O on the one side and the algorithms on the other side?
Yeah, so yes, you're right. So big O, this is I mean, that we always use big O as to find out the runtime of a program, but still big O is actually the worst case, right? But still we actually take the big O. So let me tell you one thing, as I told you about data engineering or even in data science also, right? So where we have to use a CPU cycles, right? CPU cycle, GPU cycle, whatever, right? So big O plays a very important role. Very important means, like say, even now also. So software engineering is a base of everything, right? So like say if you talk about a stack, right? How these things are being modeled, right? So you have software engineering as a base, then on top of that you have data engineering, on top of that you have data science, right? So wherever you are writing programs, wherever you are so having a computation, okay, where you use a CPU cycle, big O comes into play, right? But you also told about one particular thing, that nowadays we are into cloud, we are into distributed uh, say space, where we use cluster of servers, right? So where we can form a big cluster by using community hardwares, right? I mean, we can actually use a some 5 core system, and probably set a 4 core system, and we can use a set 10 system. So where we have 10 into 4, which is like 40 cores in total, right? So and if earlier you say think about it, that you want to have a 40 core in one particular laptop or particular say probably say one system, that is super expensive, right? So that particular part is still there, by the way, so because as I told you, that the way how we create clusters, right? So it's very important that how your programs are using the codes. So so if I talk about example of Spark, right? In Spark we call something called Spark optimizations. Okay, so in that optimizations, so this is the one particular thing what we look into, that how you can optimize a program to find out that how it will use lesser cores. Okay, or I mean, yes, of course, that we give them more cores to actually have more parallelism. More cores means like you have more threads, right? And more threads means you have more parallelism, so faster way how we can process that. But you think about it, that each core is working on one thread, right? And one thread is your one particular part of task, right? And think about it, that you have like really horribly coded that particular part of code, right? So what's going to happen is this, that that particular piece of code will take a really long amount of time, right? And your whole pipeline will be impacted, right? So that is the reason, that I mean, so if you talk about a code software programming, right? So when we talk about competitive programmings and all, right? So where your runtime, if it is more than probably, some millisecond, that is a problem, right? So maybe for data engineering world, okay, we might think about that. We have got a cluster of systems. So why do we have to care about? But yes, we do have to care about it. But I'll tell you one more thing. Let's talk about serverless. In serverless, you pay for your execution time, right? Then in that case, think about it, that your bigger notation or your say runtime plays what important role. I mean, if your code sucks, you have to pay more, isn't it? Like, it's not about that how much RAM you are using. Probably if I talk about Java, how much heap you are using or how much CPU cycle you are using. It's about if you are using, you have to pay for it, isn't it? So that's the way. And if we talk about that, we have to go serverless. We have to be really careful about that how we are programming, how the programs are being programmed. So in that particular case, your big notation plays a very important role.
Thank you so much, Pritam, for Pritam sir, for demystifying a lot of things which I had from my beginning of engineering. Most of the experience of all the softwares are through meetups or somewhat through some of the other problem statements which I have faced. Thank you so much for giving such a wonderful insight. I think audience are going to enjoy it. This probably is the shortest and the most sweetest podcast that I have ever done for and data engineering aspect. Thank you so much for that wonderful podcast.
Thank you once again, Vishwas. So as I told, pleasure is all mine. So your questions were like very interesting. I mean, so it actually, gave me some time to think about my past also. So
Yeah,
thank you even from my side also.
yeah, I know. Thank you so much, sir. I think now it's time for your meet. I think you should go now. And all the things, whatever I was discussing, it's all from my experience. Somehow I have worked in some softwares. Somehow, I just got my hands dirty on all the softwares that I can get hands on. So yeah,
That is the
that's
best
how
way,
I
I mean,
just I just
as I
pay a
told
friendship
you,
question.
that the way how you are progressing for the education, right? This is the best way. I mean, I'll be very honest to you. I did not take this particular path. I mean, I realized right now, probably, after spending almost 5 years or 6 years in the industry, after that, I actually realized. But so this is the first question what you asked, right? You are the answer.
Yeah,
I'll be very honest to you. This is the way how I mean, that how we should look towards education.
yeah,
Learn something, see how you can implement, see how you can, apply that. Now, I always believe in one particular statement. I forgot that great person who actually gave this statement. Is this, that knowledge is not, or knowledge is a potential power. Knowledge becomes power when you apply it.
yeah. No, I
Okay, I
can
mean,
get it.
we call about that knowledge is power, right? I don't say, I mean, like, not me, that particular person told that knowledge is a potential power. That knowledge has a potential power, but you can actually use the power of knowledge when you apply it. So
Yeah,
that's very important. That's very important. I mean, just theoretical knowledge and all that stays in your brain or your mind only for a few days and will go away. I'm telling you. So
yeah.
great, Vishwas.
Thank you so much, sir. Thank you so much. I think it's time for us to leave and time for me to go for the next podcast. Thank you.
Bye bye. Take
Bye
care
bye.
and good night.
Yeah.